last up, we're going to hear from PHMSA. Let me find the right presentation. From Max Kieba, who's an engineer in the Engineering and Research Division of PHMSA, and he's one of the leads at PHMSA on leak detection and rupture detection, and he's going to provide us the PHMSA perspective. There it is.
Thanks, Carl. So one thing I do appreciate hearing here is some realistic discussion, which is fantastic, but what we hear outside is not always realistic. So here's some of the interesting things I always see in the news. I'm also on Safe Pipelines, and I see this stuff coming on. So you see things like we have robust system integrity that meets or exceed all federal regulations. So for one, the regulations are minimum safety standard or minimum requirements. Yes, many companies go above and beyond, but that tells me maybe we need to raise the requirements of the federal regulations. But what happens there when we try to raise it, right, to at least what a lot of operators are doing, we get yelled at, well, you can't possibly do that. So, you know, these kind of things bug me a little bit. It kind of says, okay, what's going on with the regulations? Robust, state-of-the-art, yada, yada, notify us in real time. I think you already heard here that's not realistic in all cases. The third bullet, we invested billions of dollars in safety and integrity to make preventing leaks and spills our highest priority. That tells me two things. You know, if I were the public, well, you're putting all this money into it, but we still have leaks, so what's going on? I think you already heard in this panel there are reasons why it's challenging. That also tells me the other thing, are you giving up on all other aspects of your system, your integrity management, and just hoping leak detection picks it up? I know that's not really true, but again, when you see stuff in the news, I think that's how it's sometimes read. And then the last one is always a fun one too. If there's a change in pressure or flow, we can remotely and automatically shut off flow within 3 minutes and actively train. So I guess I'd ask, is that any pressure drop? I think you already heard that's not true. And even 3 minutes, I would say, is certainly probably not practical, even in a full-on rupture. So I would say if you're a company out there, let's avoid or watch when we put stuff like this out in the news, or at least put it into better context. I think that will help all of us. So when we ask, is leak detection possible, you know, as an engineer, any self-respecting engineer will say, of course it's possible, right? But then I came from an R&D world before PHMSA. I designed wireless sensors. It's that research triangle, right? Right, fast, and cheap. Usually you can get 2 of those. You probably can't get all 3. Working for the government, you could figure out, you know, forget about the fast part. It just takes a while. We're always forced to do it cheap, right? God forbid we do regulations that cost anything. We're always fighting the cost-benefit analysis all the time. And we rarely get it right. So either industry's mad because we're pushing the bar, or public's not mad that we're not doing enough, right? Then vendors are not happy because they want us to just require their technology because they have a technology that'll save everything, right? So it gets challenging. Second bullet, Rick Cooperitz is here, but this is a good Rick Cooperitz. It's not rocket science, people. But it can be challenging. Certainly fluid dynamics is challenging not only within the pipe, but when it gets out of the pipe, plume modeling in the soils, when it gets to the atmosphere, it can get challenging. So it's not so easy. So hopefully the public might start understanding some of that, and hopefully this conference helps that out. Cost versus complexity. Certainly higher cost and complexity doesn't always translate to better performance. We talked a lot about these already, but it's one of the many layers of defense and pipeline safety. What we often see, though, is all the layers don't necessarily talk to one another. So unfortunately, the corrosion folks, the O&M folks aren't always talking to the leak detection folks, but usually what happens when there's a leak, the leak detection people get in trouble. So we're trying to drive a discussion. I know API is doing that a lot, and others, on this idea of looking at the entire system for all your layers of defense to see how they all can play together. We've already talked about the people, technology, procedures, and the operating environment. So it's not just about the sensor, but how well are those people trained. And certainly leak, and yes, any one focus on one discrete element without considering all the others, you're setting up your system for failure. And by system, I do mean the pipeline system, the people, the process, the company, us as an industry, and the country, et cetera. Leak versus rupture, we always have that confusion out there. Someone's calling it a rupture, it's not really a rupture. Someone's calling a leak, it really is a rupture. So trying to figure out those nuances and what's different, I think would help all of us as well. Things we see, vendor claims don't always perform as advertised. My favorite thing is when I get from leadership, hey, this little device can say 0.01 gallons per minute. Why can't we just do that across the board? Well, usually it's challenging, right? So you have to think about how it's applied, and even with the fine tuning that a lot of operators do, it still doesn't even meet their expectations, let alone when you try to apply it across the entire pipeline system, it doesn't always work. Users don't always have a good handle on capabilities and limitations, and I think that goes into the training of your individuals part of it as well, making sure you're training your folks properly. When new technologies come into your umbrella of tools in a toolbox, make sure they're aware of what's going on. A lot of talk today, and traditionally we've seen limited use of external systems, but I will agree what I'm seeing is a lot more testing of the external systems, whether it's the fiber, more in the flyover type technologies, improving those for both gas and liquid, et cetera. Culture and perception issues we talked already as well, but it was good to hear the leak first, because what it used to be, right, is we'd always hear it can't be a leak, prove to me it is, let's keep that pipeline going. Next thing you know, more oil is pumped in the ground. We are seeing a change in that mindset of the culture and industry. It may possibly leak, prove to me it's not. Yeah, there are still some issues where that's not true. Public awareness and perception, I think it goes both ways. One, hopefully the public is more aware of some of the challenges. At the same time, hopefully industry realizes how much of an aid public can be. So let's be realistic. Some of these small leaks, the public will be the first to find it. You have a lot of boots on the ground folks you can help. Farmers out there all the time. They're out there more regularly than even your regular personnel. So try to work that public awareness a little more effectively. Having said that, on the other hand, I do hear a lot of companies say, no one ever called in a leak. And then when an incident happens, such as a gas incident, next thing you know, someone says, oh yeah, I thought I smelled a leak, or yeah, I called it in. The operator never got that they don't have records of getting called. So if we could improve that public awareness aspect as well. We already talked about the PR spin, so let's just watch that. Rebecca did ask me to talk about worst case discharge. So in part 194, this is just for oil pipelines, but we typically look at historical discharges, breakout tank capacities, and pipeline calculation. I will say typically it's based on a full-on gill and seed type rupture in a pipeline or a full-on loss of containment in your breakout tank. So quite honestly, it's not going to help you too much on the leak side of things, the smaller leaks. And typically it's the breakout tanks or that usually gobble it up. Having said that, we have been dinged through the years on whether or not we're looking at those properly for adequacy, so we are looking at that more close. It can't be an engineer without putting some slide on some kind of calculation, but here's how we calculate the pipeline worst case discharge. I will say we are starting to, anything less than 10 minutes, we are starting to do red flags and send it back to the company. So we used to get it all the time, oh yeah, I could do this in 5 minutes, no problem. It's also, this is really the best case scenario. So we talk about worst case discharge. Some people call it maximum response time. I think it's fair to say this is the best case scenario of response time if you're talking 10 to 15. Worst case are things like we miss it. We take 17 hours, a couple days to finally find that leak, sometimes weeks. Initiatives we're doing, MultiStep Approach, rulemaking, research and development, engagement of standard development. A lot of these you already heard about. Hazardous liquid rule, you heard the final rule is pending. Yes, it would require all lines, including non-HEAs, to have leak detection systems. I will say the public was right in challenging us, saying, okay, you expanded it, but you didn't really say what the standards were for leak detection. So yeah, PHMSA will wave the flag and say, well, you have to follow all of the parts of the code that already talk about leak detection, but in all fairness, we're probably still not getting that right. Things like integrity management, it talks about looking at swiftness of leak detection. We don't always get it right. We're trying to do better, but we're not quite getting there. OQ rule, final rules pending. The one good one about this one is team training. That did come out of Marshall, the Marshall incident where it appeared to be a leak, you had alarms going off, even a controller, or one of the controllers thought they saw something, but your supposed expert said, nope, it's not a leak. Next thing you know, they're restarting the line, pumping more oil. So I think this will be helpful in the team training aspect to everyone's experience and their individual capabilities, but working together as a team, understand what happens, who makes the calls, things like that when something happens. And yes, the rupture detection rule, Carl is right. It is only ruptures for now. We did have a discussion going into this, how can we make it into leak detection or a leak detection standalone rule, but with everything going on, we tried to roll it into other rules. This one should be interesting though. We are going to try to at least define what a rupture is by some kind of percentage of flow over time. We do anticipate it's going to be sensitive. We anticipate we're not going to get it right. We anticipate some discussion. But at least if we can set up what the definition of a rupture is, then maybe it can carry over to some considerations down the road of what at least a leak is. So we can at least draw that line of rupture versus leak. And certainly your valve placement versus your rupture detection, how does it work together as part of an overall incident response? Here's some R&D we put together, and this is only since 2012. I think since 2001, we put about 10.6 million into research, and we've put 6.2 only in the last 4 years. I'm not going to go through each of these, but I think hopefully what this shows is covers the gamut, everything from distribution to gas transmission to liquid detection, even things like your meters in your house to detect any kind of methane leak, to some of the flyover type systems. And David talked about our R&D project on improving system redundancy and design. We also have others that any new technology that comes out, what are the right metrics to evaluate? We are considering, well, I think we are going to do it, an update to the 2012 study. We're just working through some of the contract issues. The idea there is we're going to revise that whole report from 2012, but certainly look at, one, some of the newer technologies in use today, but also some of the more cutting edge stuff that are out there that maybe aren't used currently now. So yes, there's some discussion at looking at some of the accident data as well. We're working with some thoughts on that. The question mark is we just don't know when, just because with the continuing resolution, question came up, is it a new project or not, since it's now 4 years old. So, but we are looking. You heard our administrator talking about the cutting edge. I will say she does walk the walk. When they came to me in October, September, say, hey, can we update the study in 2 months? I'm like, oh, that'll be interesting, but we're going to figure out a way to get it done, and and try to figure out to really push the innovative understanding. Some of these technologies aren't just there yet, but try to at least push that discussion a bit. You heard a lot about standard development, 1175. I do want to acknowledge the 1168 on control room management. They did work in some of the new aspects of team training, roles and responsibilities, other aspects. We keep talking with RP 1130. I know there's some interest in updating that one as well. Some of that has some metrics and requirements, but they're going to push it as well. Gas, I have a question mark here only because we're not aware of gas standalone standards. I know they're engaged in 1175, but we're not aware of standards specifically for gas detection. And also external sensors. There's been a lot of requests, let's get some kind of external sensor standard. Maybe with some of this R&D work, we'll get to a point of potentially getting that framework together. So with that, that's all I got.
All right.
Thank you.
Thanks, Max.